Hello everyone, my name is Laura Sanchez and I'm your host today. Welcome to Blended and Flipped Learning Theory Overview. This is part one of a two-part series. This webinar is brought to you by Networks. Networks is a part of MATEC, a member of Workforce Development in the Division of Academic and Student Affairs at Maricopa Community Colleges, and funded in part by a grant from the National Science Foundation. This webinar is being recorded, and we will provide you with instructions on how to access the recording and slides at the end of the webinar. Now, the service we're using for the webinar is Blackboard Collaborate. If you're familiar with Collaborate, please raise your hand now. And I see some of you are and some of you are not, so let's do a quick review of some of the key features of Collaborate. Here we have a screenshot of the Collaborate session. Notice the whiteboard. This is where the presentation slides will be displayed and most of the learning will happen. Then you'll also see the participants box. And the participants box is a list of everyone who's logged into this webinar. You might notice friends or colleagues in there. Next, we have the chat box. The chat box is where you should type your questions and comments. I'll keep track of any of those questions so that we can address them as time permits and during the question and answer breaks throughout the webinar. You can customize these components that we just talked about using a simple drag and drop. So you see how I did and how I have my participants box now below. Now, if you'd like to send a message, you can do so here. Make sure to send the messages to this room. And if you want to send someone you know a personal note, that's fine. Just please be aware that the moderator and presenters do see all of the comments, even if they look like they're private. You can do that by double-clicking on a person's name, and a tab will appear. Now you can have a private conversation. Just make sure that if you have something to share with this room, you select the Room tab first and send the message from there so we can all see it. You'll know that the person you sent a private message to has sent you a message back by the bubble next to their name in the tab. Okay, now Collaborate has also some great interactive features that we're going to be using today. And the first feature I want to show you is the emoticons. The emoticons is at the top of your participant box and allows you to provide feedback to us. You can try it by clicking on the smiley face. So let's go ahead and try that now. Great. And then of course we have the raised hand. If I ask you to raise your hand again, please do though by clicking this. Perfect. Looks like everyone's getting a hang of that. So now let's get started by giving a round of applause to our first presenter, Mike Lasecki. Mike?
Laura, thanks very much. It's my pleasure today to be on this webinar and talk about blended learning. Blended learning isn't a new thing in any way, but I think there's been so many advances on the technology side and the way we think about it. It's exciting to have this two-part series starting today. Let me tell you a little bit about my colleague, Ava Toth. Ava is an assistant professor of science education in the Department of Curriculum and Instruction Literacy Studies at West Virginia University. Ava received her teaching credentials in biology and chemistry at the University in Budapest, and subsequently she received her PhD in curriculum and instruction at the University of Illinois. She then completed a number of postdocs, including one at Carnegie Mellon, and recently she's focused on biotechnology in-service teacher prep prior to her joining the group there in Virginia. Ava's research interests in general lie in the area of science curriculum, the development of that curriculum, the development of assessment, and her interest in science education, I think, is just a unique set of credentials that brings us here today. Now myself, I have the privilege of being the director here at MATEC, and also have a background that's in chemical physics, and I'm particularly interested in the application of technology into learning environments. And so that's my opportunity here to join you today. And you've already met Laura Sanchez. She's working in the background here at MATEC Networks to produce this particular seminar for today. Ava, would you just say hi to everybody online for a minute as we get started?
Hello everyone from West Virginia, home of the Mountaineers.
Thank you, Ava. Your voice quality sounds just great. Let's go ahead. Today we've got several objectives, so let me review them with you. And I think these are pretty good ones in a way, right? What we would like to do is develop a common understanding of blended learning, and in particular the terminology that's used here. I think that's important for us. Number two, how do you develop a blended approach to instruction? I bet many of us are already doing it and maybe don't think of it in quite such a formal way. Number three, how do we implement blended learning using active learning, such as inquiry-based learning? And we've got a bunch of interesting examples to show today. And then finally, how does one think about this as an instructional design sense? How do we apply instructional design principles to blended learning? So those are objectives for today. Now I've had an opportunity to introduce ourselves to you. Let me ask you to return the favor. On this slide, we're going to allow you to use the whiteboard tool, and that's the markup pen that you can see right there that we're pointing to. And I'd like you to mark where you're calling in from today. So would you go ahead and click the slide there, Laura, to the next page? Good. So everyone, please take their tools. I'm going to grab mine and mark up on the tool. And there's me sort of marking a yellowish arrow in Phoenix. That's good. I see people from around the country that are logging in now, up in Minnesota, up in Colorado. Excellent. Just give another 10 seconds to practice. We're going to ask you to use this whiteboard tool a little bit later. So excellent. We've got people from all over the country that are joining us today. Now we're going to ask a poll question next. First, let me show you where the polls are. So on my flashing dot here, you can see that we're pointing to where you'll respond to the poll. So please take a note of that. Now I'm going to change to the polling question. Now when you hear the term blended learning, I'd like you to respond A, B, C, or D. So A, that's something I'm doing right now. B, I probably incorporate blended learning without really realizing or thinking about it. Number C, I wish I understood blended learning concepts in more detail. And D, my college doesn't provide resources in the area of blended learning, at least today. You may answer, you think I should say A, multiple choice, more than one response, but you've got to choose one of these responses. So please go now to right above the participants list, right there where you see the little icon for the poll. Click on it and please respond to the poll. Do that right now. Good, I see a number of people coming into the poll. Thank you. Laura, would you please display the poll results? Okay, so let's take a look, folks. We've got a pretty even mix between A, B, and C. That's something I'm doing right now. B, that's actually what I answered. I probably incorporate blended learning without thinking about it too much. And C, I wish I understood blended learning concepts in more detail. What perfect! What a perfect audience response to have as we go into this session. So let's get started. So what do we mean by blended learning? Well, obviously there's lots of definitions out there, but here's one. Blended learning is the thoughtful fusion of face-to-face and technology-mediated learning experiences. Not bad. Fusion of face-to-face classroom stuff and technology-mediated learning experiences. Okay, I can buy into that one. I like it. What are some of the basic principles of blended learning? Well, let's look at the first bullet. Oral and written communication, that's the core, as well as interaction and engagement with many different types of resources. Now these resources could be audio, clips, podcasts, video, graphics, simulations, immersive environments, etc., things like that. So those are the different resources you add to your regular oral and written communication. And then you've got those resources now blended into a unique learning experience congruent with the context. Oh, I've always wanted to use those words, congruent with the context. That just sounds like the right sort of thing we should be doing. And then most fundamentally, most importantly rather, blended learning is a fundamental redesign It changes the structure of your approach to teaching and learning. So it's a different way of thinking about things. Okay, basic principles. There's some key assumptions of this area. Number one, again, thoughtful integration of face-to-face and technology-mediated learning. That was one of our key assumptions. We just talked about it. Number two, a rethinking of your approach to course design, how you design your course. You know, you hear today, I swear I get 1,000 emails that say how to increase your student engagement. Well, it's certainly a big issue today. Number three, it's a restructuring as well, and you're really thinking about replacing traditional class contact hours with different opportunities for students. So it's a restructure in that way as well. And finally, it's an optimization of technology resources. And that doesn't mean going to your administration and saying, I need $25,000 to implement this technology. I think really what it means is using what exists today, not necessarily adding on some big layer. I think my point here is this can be done in a straightforward way without a huge amount of effort. So let me give you an example. I often learn the best by example. So when I was teaching Chemistry 130, which is, depending on the state, I guess, it's your conventional first-year chemistry courses, we would always at some point talk about acid-base titration. Now in a conventional sense, this is what you would do, or what I would do rather. In class, I'd say, all right, students, today we're going to be talking about acid-base reactions because you've got to know that first before you can understand titrations. So I would draw things on the board and I would want them to take notes. Then I would say, well, important to understanding these reactions, you've got to understand normality or molarity as well. And then I would tell them about the concept of a titration and what an endpoint was. So I'd be lecturing and they would be taking notes. Now I would say, at home tonight, I want you to do the following problems, which are largely calculations. You know, calculate the normality of the solution, calculate the number of milliliters required to reach the endpoint. And I want you to turn in those problems tomorrow when you come in. And say, and tomorrow we're going to do a lab which is how to do a titration. And then all the students would get in there and they would do the titrations. So that's a pretty conventional approach, right? Nothing different about it. They got some hands-on aspect. Let's look at another approach to this. Let's call it the blended approach. Once again, acid-base titration. Now here I'm doing it a bit differently. I'm starting my class by talking about how acid-base titrations are used in the real world. I'm going to use some of my own experiences. I used to use the darn things when I worked at a chemical company at night as I was going to school. So I would talk about the use of those in the real world. Then, online, I could do that in the classroom or I could send them to the Learning Center or whatever. I'd say, I'd like you to view these videos on titrations. And once you've done that, I want you to practice a simulation of a titration experiment. I want you to actually do it online, do a titration online. The next day, when the students return to class, this is where we're going to do their homework. So in the classroom, we're going to practice calculations in small groups. And I'm going to wander around between the groups and work with them. And then finally, I'm going to blend in the lab, but in a little bit different way. I'm going to use the lab, not as a lab assignment, but as a performance assessment. I'm going to say, okay, now that you've seen titrations, you've practiced the simulations, I want you to demonstrate to me that you can do one correctly, and that's going to be a large basis of your grade for this segment of the class. So you can see the different approach here where you're blending these different things, using some of the technology back here in the second thing. Now, a lot of you are thinking, yeah, okay, I understand this. It's pretty straightforward. It's pretty obvious. But I think as you get more into the design for your own classrooms, you can even add more to this. Now, let me show you, just for fun, you know, how this might work. So what do? I go onto Google, of course, and I Google acid-base simulations, and I find this one that was developed and I have the link to it somewhere here, at a university. So I then did an intro to this that my students would look at. And so we're going to see my introduction. It's coming up right now. It's going to go to your screens, to this simulation. Now you may have to press play on the screen. If you see a play arrow, go ahead and press play. And let's just listen.
This is a brief simulation for demo purposes of a titration simulator. I have hydrochloric acid, sodium hydroxide, strong acid and a strong base, an indicator solution, and I can measure the pH in the flask. Here I set the volume of sodium hydroxide in the burette. I click on the stopcock, and now you can see the drops are falling. Notice how the pH is increasing as the base is added. I'm at about 13 milliliters so far. No color change yet. Oh, suddenly a color change. We've reached the end point. Now I can use this simulator to change my composition.
Okay, thank you. Would you close that for us, Laura, please? So what I was showing there, I used I'm fairly novice at this. I used a software called ScreenFlow to just record that. And for my students, I would have said, all right, before you do this simulation, I'll just give a quick demonstration of how this would work, and then they would go on to do that. So I just wanted to give you some of the aspects of blended learning that we're talking about today, and just show you how I could quickly do that. I've got another example for you later on in the presentation that shows it in a little bit more detail. Now, I'd like to invite you to type any questions or comments that you might have into the chat window, and you'll see that on your lower left in the chat box. And if you have any comments or questions you'd like to ask at this point, go ahead and type them in there now. Laura, do we have any questions before we go ahead?
Yes, I have a couple participant questions here on my end while we wait for people to type in the chat. One of the participants says, I was struck when you asked us to respond to the poll about my college providing resources for blended learning. I am not sure if they do or do not. How would I find that out? Good question.
Yeah, it is a good question. So, like when I was preparing for this webinar, I decided, well, I would go to my own college and see what resources they offered faculty, and I was surprised how much there was there. Our colleges have things like centers for teaching and learning, and I bet you many of your colleges or universities have something similar to that. And I found a number of things. I found some workshops. I found a couple of short web presentations on blended learning. You know, this topic has been going on for easily, it must be 4 or 5 years now. And there is opportunities for professional development. Then I went to some larger national associations and found that they had resources for blended learning. And then just to toot our own horn for a moment, the Maytech Network's digital library, I searched that and found a number of resources on blended learning. So let's get back to the answer to the question. If you're a faculty member at a college or university, there's a good chance that your instructional support area has resources for you. To what extent they have those to make videos and things like that, I'm not sure, but they certainly have guidelines on how to structure your current offerings, your current courses, into a more blended format. Another question, Laura?
Yes, thanks, Mike. Here's one. I don't really have time with my teaching load to develop things like simulations myself. What options do I have? I hear that one a lot. Go ahead.
Yeah, me too. It's certainly the case for all of us, isn't it? You know, you have your teaching load. How is it that you're going to develop simulations? You might not have the skill to do simulations. Well, these days there are so many different simulations out there. Like that titration one, that wasn't something I developed, but rather it was developed at another university. So in that YouTube video, I was careful to put in the comments section the attributes, the recognition of the developer of it. That's important. And I think what you need to do is really sift through what's out there and make a good judgment of what's useful to you. I mean, I found, 12 different videos about titrations, some done from commercial places, some done from .edus. So I had to make a conscious decision on which one I wanted my student to see. I think today there's so much out there that you can often find what you want.
Thank you, Mike. Okay, let's go ahead then and turn it over to Eva.
Thank you. And let me shoot, that's me screwing up the things. Just one moment. Okay, Eva, thank you again for joining us. We had an opportunity to introduce you, and we'd now like to turn it over to you, Keys to Success with Blended Inquiry Learning. Go ahead, Eva.
Good to be here, Mike. Thank you. I'm going to reflect exactly on the previous question that a person asked, and that was how can we go about finding these simulations I don't have time to develop. I used to be in an environment where I actually was able to develop these tools for myself, and then I realized, no, I need to teach science, I don't have time for this, I need to work with other people to develop it. And then I worked at places like supercomputing and with software engineers who were developing these tools, and we created pedagogies around them. So what happens then is there are these really nicely developed software tools that reflect on a concept or a process and give you a lot of nice pedagogical tools to work on that one concept or several concepts in one domain. But really, that's just one area, and there is no generalizable skill or no generalizable idea of how to find and how to edit and modify those existing software tools. And my talk is going to be exactly about showing you some of the ideas that you can use to appropriate these existing software tools for your teaching.
That sounds very good. Go ahead.
Yeah, I'm excited about the area, and I actually gave a couple of publications at the end if you would like to read more about what I do. Those go much more into the detail. Here I am focusing on just some basic instructional design principles. So the main idea is what ways can we optimize these existing technology resources for learning. So when we talk about learning, one important thing that we need to go into is how to generate this active learning environment in science. We work with the concept of inquiry learning, which is a general strategy that incorporates active learning as well. Inquiry learning is used in a number of ways, so you all probably have heard about it. And so we will go into a little bit about what ways has been inquiry learning conceptualized at different levels, and then create some application examples about how to go about with the instructional decisions. So let's examine, just like Michael did before, let's examine an everyday situation in the area of biotechnology, just because those were the tools that I recently used and the topics I recently used. So this is from my prior research. I actually have data on some of these users and data on learning some of these on the papers, but we will not have time for that. So let's go to this everyday example. Usually, when you want to do a laboratory, such as gel electrophoresis, you give a protocol to your students. And the protocol will say something like this: given, and we need an end there, given the materials at your station, use the following protocol, and you give the handout, to perform the DNA gel electrophoresis. And so what happens then is there is gel electrophoresis tank and with some wires and the battery in the and somewhere there with some pipettes. The protocol will tell students to now first what you do first, what you do next. For example, pour the gel, tells you about some precautionary ideas of what to be careful with. then pipette in the different samples, then close the lid, connect the batteries, and run the experiment. Now, several of you have done things like that before, or just ran a regular laboratory experiment. Think of these regular laboratory experiments to do in this area with this idea of continuous protocol. I'm going to ask you a couple of questions, whether these are in your thoughts, based on what you know right now, are these inquiry learning? So if you think that this protocol, the way I examined, could fit into the concept of what you know about inquiry learning because students are doing hands-on work. That is one good example. I'd like to see who thinks that. Or maybe somebody would say yes, because students can check the quality of the outcome gel and they know how well they did. So there is a goal there, how well they did. Or some of you might be more suspicious and say, well, this might not be an inquiry activity because the research question, the research goal has not been clearly stated for students. And these questions might be biased a little bit, but just let's go ahead because there's a lot of confusion about what can be considered inquiry learning and why is it different from just hands-on learning. So I wanted to ask these questions. Yes, oh, that's very interesting. Oh, we didn't get a whole lot of answers because not everybody answered yet. Can we hold back with the, or is this all? Okay. So what was the poll result again, Laura? Sorry. Okay. Yeah, so a couple of you kind of stood back a little bit, but basically there is an idea that if you do hands-on work, that is actually inquiry learning because you're figuring things out hands-on. And the second idea, those who answered B, it's a very valid point. Both of these are very valid points. Well, there is a goal, go and figure out whether this process works very well. Well, here is the big difference with inquiry. Whether you have a goal as an instructional designer, as an instructor, and what your students' goals are, if those are different, then you have a lack of match in your activity and a lack of match of motivating students towards developing and finding out things for themselves. So if there wasn't any question stated regarding whether that is possible to separate, for example, DNA fragments from each other with this gel electrophoresis process, students might just be clicking and mucking about and following the protocol, but they really don't have an idea of what they are doing. So what we're trying to focus on the process is the process of inquiry learning that includes finding, locating, gathering, analyzing, and critiquing information for a purpose. So look, for example, this definition here, which is just one simple definition. It includes different processes that need to be, and I need to add this to this, these processes need to be generated by a guiding question. So what are these processes that we really need to focus on? First, we need to set goals for students. There needs to be a guiding question. Then there needs to be a process, a protocol, a design, a way to collect data so that students can then analyze that data and then find out answers to those questions and maybe even form rationales for the mechanism that brought about those processes. So this is all nice here, but there is a big but in this, just like there is in pedagogy. How can we implement this in practice? Well, what if some of your students are not ready to ask these questions? What if students are not ready to analyze and find and measure their own data and then analyze it and formulate questions, formulate rationales about and explanations about this data? Well, enter the levels of inquiry. Enter the concept of levels of inquiry. So I'm offering this paper from you that is very eloquently explained and developed by two researchers here, actually 3 articles, and I'm citing at least one of them, the Bell article, in the end. I encourage you to look into it. So let's look at this table in a little bit more detail and figure out what it tells us. There are processes in inquiry learning. There needs to be a question, there needs to be some methods, and then some solutions for data collection, for data analysis. This is my structuring it. Some people will structure it into 5 phases. I just give 3 different phases just for ease of interpretation. So we need to, if we can provide questions for students, if they are not able to develop their own, we can provide methods for students of how to do something, or can even provide solutions for the students, and in essence, creating a protocol that is now confirmatory inquiry. They've done everything similarly to what they did with a protocol before, but now we asked a question and motivated students' inquiry based on that question. They have now a purpose for learning. Well, this is not much of inquiry, but if this is what we have to do, it's a good starting point. We can call it confirmatory inquiry because it's not much different from a protocol. We basically just gave a question to students. However, you can wean your level of support gradually. For example, you can raise your level of inquiry in your classroom by just giving a question and adding a description of the method by which the students will generate this data, but don't tell them what they will find out. Let them figure this part out by themselves and then have a conversation. Now, even with the same tool and the same process, you elevated the level of inquiry a little bit because now there is have a little bit more stakes, a little bit more independence. You can see how you can actually just ask questions from students and create a guided inquiry, or in best case where students are ready to figure things out for themselves, you can even let them ask their own research questions, develop their methods, and create solutions to create an open inquiry learning environment. So look at these examples and this structure of inquiry learning. We're going to look at a couple of examples. I did not plan this, but I talked more than I like, so I will ask participants to please enter their questions in the chat box if there is any. If there is any question on the process that I developed or any concern with the process that I explained here, please ask your question.
I have one question, Laura. Would you go back to one slide, Ava? Yes. There was one question that came up, and we don't usually give our, that solution given. I don't usually. I mean, people don't usually give solutions to, or maybe they do sometimes. Can you elaborate a little bit? Does it make sense ever to give a solution to a student?
So if you provide a protocol, they know where they're getting at. They can know where they go to. They know what the outcome is. I need to isolate DNA. At the end of this protocol, I need to have a substrate or a floating piece of DNA. If I don't have it, I know I didn't do something well, but I know what the outcome is. So it's a very simple outcome in this case, but they know it. Or if they know they will separate DNA and it's going to look in a certain way, and I'm going to show an example for you, then that solution is actually given. They just replicate it. You know that a ball will roll down in a ramp.
Sure.
And you know that the heavier ball might go farther. There's not a whole lot of question there unless you set up an experiment and your data can actually vary and you don't know what the data will be. So think about this in very simple terms.
Okay, that's a good point. And there's one other question, but I think you're going, as you go forward, you're going to answer this one. But it's a good leading question anyhow. How would you make inquiry learning applicable to the blended format? And I think you're going to be talking about that as we go forward, aren't you?
Yeah, that is a very excellent question. And how do we get students' attention from moving to what was that question here? Just reading it. That's really good. I need to get the right answer versus see what happens. Yeah.
Sure.
So
let me repeat that for you. How do you divert the learner's attention away from I need to get the right answer to do and see what happens and reflect as needed? How do you get students to shift their thinking there?
That's right. I'm going to show you a couple of examples. And some software tools will be more helpful for you in doing that, and some will be less helpful. But you, as the instructional designer, have the power here to change what that software tool does for you, even given the limitations of that software tool. So for example, just two examples that comes to mind that I use.
Sure.
Oh, here. So let's look at these questions with the following software tool. This software tool actually is listed with Michael's Resource Center for the MATEC, and is generated by the Genetic Science Learning Center. It's an excellent, long-standing software tool that will show you the process of DNA gel electrophoresis. Let me draw your attention to particular images and parts of these images so that you can have an idea of how this works, and then I will show you a very short video clip of how this works so that you can generate a basic understanding of what's going on here, even though we will not be able to explore the entire software tool. But what I'll tell you here is very characteristics of the software tool.
Okay.
So here, okay, let me show, where is my hand? Here, they will tell you the steps of the protocol and highlight which step you are performing right now. And you'll have different gadgets that are related to gel electrophoresis. Thank you. And students are actually instructed down here in the bottom of what they actually need to do. They actually have some interactive element here as well. They can grab the pipette and pipette the buffers and the DNA samples and the standards. And when they are done with the process, they actually click here in this triangle to move on to the next step. So what they are going to see during this process is the actual protocol that they have to perform with very well labeled tools so that they can have an idea of what is that they are doing. So some of the images that they will see, for example, is are related to the process of, for example, here connecting the tank, the gel electrophoresis tank to the battery, and how they collect red to red and black to black. And they can actually drag these cables and move them to connect to the battery, just like it's shown here in the second picture. At the end, there is also some sort of data analysis that the students are able to do, which is quite unusual for DNA gel electrophoresis software tools. As you can see here, they can see the outcome data. They will see the ladder, the DNA that measures how long each fragment is by size, base pair. And they can put in how many base pairs is the length of their sample DNA. They put it into these figures. So there is a little bit of analysis of data here. So let's look at what kind of inquiry support can you create with this tool, and what is there that is missing so far but you can put in there. So just for 1 second, look at that video and see, while you're watching this and while you're thinking of the images I showed you, see what kind of ways could you make this activity a little bit higher level inquiry. Go ahead, Laura, please.
Okay, I'm publishing the video. Now again, remember, you may need to press play to begin the video, and your chat box may not actually work while the video is playing.
All right, so you have a feel for what was happening here. Let me give you my idea of what I liked and what I was missing in here, and then I'll ask you for your input, but tell me what you were thinking while you were doing. There was certainly a method given, right? We knew what we need to do. There was some sort of solution given here, but the students also got an analysis activity at the end of deciding, well, not just that I separated DNA, but also how big base pairs, how long these fragments are. Now, what are the questions that are missing here? We could have asked, where do the longer pieces go? Do they stay on the bottom, or do they stay on? Do they go to the stay on the top or go to the bottom? Which of the base pairs? Why would they go longer or shorter in this particular gel? Or we could compare two different samples and show how the process of actually matching DNA fingerprints would be, and ask about who the killer was, or who was the person that was actually in the crime scene. So in my mindset, you could actually add more questions to this setting to raise the level of inquiry, and even raise the level of inquiry a little bit higher than what we saw here, and even come up as high as guided inquiry in my mind. Okay? So what were some of your thoughts while you were looking at this inquiry, and how would you be able to use this example in your own case by setting goals for your teaching? I see somebody saying that this example actually seemed to me leading a little bit, and I agree with it. The method was very leading. This is the method what you do. It was focusing on that protocol. And so it wasn't really, it was very structured, maybe not fully confirmatory, but very, very structured about the method. Could be perfectly good for some students, right? For students who really need to understand these first levels before we could ask these questions. But I would not go just leave it here, but actually ask more questions.
Ava, I thought, if you don't mind me jumping in, one of the goals would be how actually to do it, right? I mean, that's a pretty basic skill, the imparting the knowledge of actually how to do it. I mean, that was a pretty clear goal, I think, of this one, right?
Right. And also this point here, it would be a perfect activity if your goal was to see if students can follow process properly. First, we let them fiddle with those pipettes in this environment before they ruin the real ones.
Yeah, before they break the ones, yeah.
Exactly. So if they are not clicking properly here, of course they still have to learn some pipetting activities. But this certainly would be helpful to show, okay, you need to have a little coordination to here is how you where you put those samples, or how you connect those batteries, because that's always a bad problem. Students mix up which end to connect to what positive,
sure,
negative connection. Okay, so should we move on, or
yeah? Let's go ahead. Let's take a look at the next one.
So the next one is actually a little bit higher level in my mind and the way I analyze this, and I hope you're going to like it. And just look at how simple tool this is. This has nothing about the 3D structure or any pipettes or any wires or anything. But this really guides us and leads us and focuses our attention on what happens with those bands, the longer bands, which are, so there are different kinds of DNA fragments here. Some longer segments, I'm trying to show something, some longer segments and some medium-sized fragments and some smaller segments. So what happens with those? So in this example, actually, there is a lot of flexibility that students get. For example, they can change the concentration of the gel, and this is the gel here, this material here that, I don't know why I'm not able to, this material here is the gel. So they can actually set the experiment to choose different concentrations of the gel and then set different settings of voltage. So they can actually have 9 different voltages and then turn the voltage on, and the process actually will go to the end. Then they can generate a new gel, set a new experiment, and turn the voltage on again and go to the end. So this actually focuses students' attention more on the experimental design and trying to figure things out. So I'm not going to give you too much about what things, but why don't we look at this just to see first how this video works and what happens in this very short video.
And again, you may need to press play to get the video started.
Okay, so let's look at here. Obviously, there could be a number of questions that you can give in this particular situation, and the students have to have some sort of question in order to set up their experiment. So for example, they can ask here, what concentration, what's the effect of concentration of how far the different size DNA bands go? Or they can ask, what's the effect of voltage? If they can even just get their own timer and figure out whether the bands moved faster with the different voltage settings. So here again, there is a versatility of the questions can give that the students can ask, or you can set it up for students and make it a little bit more structured. But you can have the students design their own experiment, and you could just tell them, well, figure out what's the role of voltage, figure out what's the role of time, figure out what's the role of concentration in this setting. The method, of course, was given because that was, you used this tool to give this experiment. So it was, depending on how you set up your question, could be guided or structured inquiry. Solution, again, there was nothing said about the student had to figure that out themselves, collect the data, measure it, and there's different methods. If I go back for a second here to the picture only, the students come up with a different method. They can actually use a ruler to decide from the beginning to the end how far the different band sizes, the size fragment went under 2% or 1.5% or 0.6% gel. So we've done that kind of experiment before. Kind of have to be creative of how you do your measurement rather than just visual examination. So in this case, I would say the level of inquiry could be a lot higher because the software supported that, but you yourself also are able to change that level of inquiry by the way you provide those questions and what you expect the students to do as a solution and reasoning. Any questions here?
Eva,
or any addition?
Yeah, Eva, we have a question from the audience. Could you talk a little bit more about distinction between guided and structured inquiry?
The distinction is not one-to-one. That is, it's more like a feel rather than a set protocol. If you have less guidance and fewer of these elements, again, I structured it to be 3 elements and other structure is 5. If you have fewer of those guided, fewer of those determined, then you have guided inquiry. If you have more, then you have structured inquiry. If you have all of them, then you have confirmatory inquiry, but you always have to have a question to have an inquiry. So it's more of an art than a 1, 2, 3. Just imagine it to appropriate it for yourself as it works for you for the particular situation. Open inquiry is very clear. When you tell the students, ask your question, figure it out, what's the topic, here is your topic maybe. Okay, is that?
That was great.
I think so.
Okay.
Could you go back to the image of the experiment there, number 2, that shows the voltage being, that one. I think, to answer your question, if I can, this concept of interrelated variables, I think our students often struggle when you have more than one thing changing at a time, right? So here you could change percentage of gel. By the way, I know we're talking about biotechnology, but I guess this applies to across the spectrum. You could change one variable, gel percentage, as well as the voltage. And so I know I struggle with my own students on this multiple independent, or rather interdependent variables. I think as you get higher up in the levels of inquiry, if I'm saying this right, I think that's an important concept that you can help the students with.
That's right, and I actually studied these processes. You will be amazed in university classroom how many times students actually changed both variables of the voltage and the concentration without actually setting up properly all their possibilities and creating confounded experiments and then trying to reason from there with these tools. So that was actually very helpful. We actually also repeated it with hands-on setting and allowed them, the next step was to allow them to do experiments with the hands-on setting as well, because we wanted to enforce their ability to design experiments. So we actually gave them a number of gels so that groups of students can actually do their experiments with various concentrations in the hands-on settings too, just because we realized that there is so much problem that we need to focus on experimental design more.
Good. I wish I could say I never did that myself, but I did.
Just to wrap this up a little bit quick, my part up here is that one way I would do this, and that's just my thing that I developed after I worked with these tools for a while, would be that first I would probably use some sort of confirmatory inquiry myself for those students who really need the steps, the process, those who try to come to the laboratory classroom without reading the protocol. Somehow would make sure that if they don't do this simulation, they cannot enter the lab, for example, so that you protect your equipment as well as the safety of your students. I mean, they can put their fingers into the buffer and get a lot of problems with that. Then, before or after the hands-on, it's up to you. But I would then do the MyDNA, the second animation, or something similar to the second animation, similar to the titration that Mike was showing, that actually allows them to change variables such as the concentration and the voltage. Then I would say, now let's do the hands-on experiment, and then you wouldn't have to set up different gels for different experiments. Then they would just be basically fiddling with the gel, how to pour, the manual skills basically. And that would be a nice way to do it if you have the time and you can afford it. But this is also safety and money to try to do this first and outside of the classroom. So that would be my suggestion. And if you can do that on your own with some of that, some of your work, I believe that would be a nice way to try to use your own inquiry expertise and develop your own inquiry expertise teaching with inquiry for active learning.
Okay. Let me try one on you, if I can. I got excited by watching your, the development of the things that you did. So let's take a look at a different domain. Ava, I know biotechnology is a wonderful thing, but obviously RF plasmas are much more important in the world. I'm joking. Today, for our third example, I'm going to show a simulation. This is part of our blended learning approach. So here's the goal for students. Using a simulation, you're going to conduct 6 experiments to demonstrate different conditions for creation of a plasma. Plasmas are used, I think many of us know, across a whole spectrum of industries. So there's just a lot of interest in doing this. And they're expensive. I mean, the equipment is expensive, hard to maintain. So it's good place for simulations to give students experience. So in the preparation of this webinar, remember I'm not sure I have all the greatest skills here, but I decided that what I would do is show you my approach to blending this into my class. So what I did was a 2-minute and about 50-second screencast. So I played the simulation on my desktop and I captured it with a software tool, which I'll talk about in a minute. And then I posted it on YouTube. And we're going to see that YouTube video in just a moment. But I would tell my students, I want you to first view this video that's coming up right now, and then do the simulation. So let's take a moment, and you may have to press play on this, and let's let the demo run so you can see the interactivities. So Ava, I wondered what we thought. I think, again, I'm not exactly so expert at doing these inquiry-based things. I wonder, what did we see in this simulation? Maybe you could ask me some of these questions and I would respond to you and then tell you how I thought about this.
Right. So Michael, the important thing for you to hear to know is 2 things. Yes, we have these levels of inquiry. We went through that. But the next thing is that it's instructional, and remember this, everybody knows this, but the next thing is to remember that instructional design has this golden triangle, right?
Yes.
You have goals, you have to set the goals for your question. Then there is this activity, and then there is an assessment of the activity. Now the three have to be interrelated. If you have a goal, and the activity doesn't match that goal, well, we consider with that activity or the goal a little bit, like I showed you with the inquiry level. But then you also have to make sure that you assess it somewhere, and you assess the kind of skills that you wanted to teach. Now, assessment is a big deal. I suggest we have a different discussion about that sometimes. But let's just say stay with the activity, which is the learning lab here, the virtual lab that you were showing the simulation of the plasma of activity, and your learning goal. So first, you really need to know what is your goal. What are you trying to teach?
Well, here's what I was thinking when I did this. I had actually, without really realizing it, I had different levels in my mind, right? So my first level is I wanted the students to sort of know what a plasma was, so very superficial goal. And then number two, there's two key parameters that govern plasmas. There's many parameters, but the two key ones are what the pressure is in the darn thing and how much power are you pouring into it. And I thought if they would get that sort of idea, they would go a long way towards actually being able to understand these things. So I sort of focused on my fundamental concepts, what a plasma is, and number two, what are the main interacting parameters. I really was focused on a very basic level here. But then I had ideas for going further. But that was my first set of learning goals.
So the point here is that you can set up different activity levels with this, but you need to be very clear for what your goal and for what your goal is for the learning, and then the students need to have the same goal. So if you wanted them just to understand these two variables changes the plasma creation, then you give them that question: what ways does the pressure? What change? What ways does the power change the experimental outcome?
Yes.
So those would be the questions. Then you give them this software tool to experiment with, and come back with some numbers that they can map in a graph as an outcome, and then analyze the output that way. So
yep.
The answer, the protocol here to think about when you look at any software tool is start with your goals for that activity. Then select the software tool. You already had one. Select the software tool. See what level is there that you can, what kind of ways can you, what kind of inquiry can you create with that particular tool? Because tools will be, again, restricted in some way, but you can add your expertise by the questioning, by the method, by the pedagogy that we went through today to raise the inquiry aspect, raise the students' active learning aspect. The students become more active based on what you do with this software tool. So you select that software tool, and then you complement the features. Without your explanation of goals, without giving them a scenario of why they want to do this activity, without helping them developing a guiding question, that's really hard to create an inquiry. So that's what you do with your instructional design expertise, to add those goals, to provide methods, click on these buttons to change the power and the pressure up and down, and create experiments, and then ask what's the highest pressure, what's the lowest pressure that you could do, and what were the pressure and power relationships that you came up with. Then you ask the students within this scenario, at the end of the experimentation, you ask them questions. What happened? What did you found out? And tell me why. That's so important that very often we just forget to ask, tell me why. We expected the students, well, they got the data, they're smart people, just like we do, they figure it out. No, they have to explain. You will be amazed how many times they will give you a different reasoning. And that way you actually determine their conceptual mistakes as well. And again, the assessment is the last part, but that's probably a different topic. So far, I just have to say we need to coordinate it with these guides that we set up.
Okay, I can't resist asking this one thing, and actually it came in as a question from one of the participants as well. You know, you do these virtual things with students, but a number of us struggle with this question about assessments. And I know it's a big question, but take this one for example. How would I design an assessment? Would I have the student show me that they can operate the simulator? That doesn't seem exactly right. Do you have any thoughts I know you haven't seen this a lot, but what would I do as an assessment here? There was a couple of participants asked that same question.
So assessment is a huge, huge part, and it's hard to discuss it in a short, I don't know, I don't even know if we're over time or not. But
we've got about 5 minutes to go, yeah.
5 minutes to go. So assessment again depends on what you wanted what was your goal with this learning activity. If you wanted them to be able to operate the machinery, and they went through that process and they reached to the end because they pulled the pipette to the right way, so somehow they went to the end, and then they actually do it on hands-on and they do it well. That's one way. That's one way to assess them, their performance. So performance assessment is one method. If you want to look at their reasoning, well, you either have to ask them during the performance what they are doing, or you need to ask them to write down some explanation, and the method is called essay writing method, where they actually write down their explanation for their processes. That's a different assessment. Performance, essay method. Then of course we have the short answer questions, which is a very basic, whether they recognize the answer or not. And the multiple choice, which is really just multiple guessing. But if you really want to, and I'm telling you like a big lecture in 2 minutes here, if you really want to measure their understanding and comprehension, you don't ask this kind of simple question, but ask the reasoning questions. And you can only do it with an essay or some writing analysis or recording their thoughts, or asking them what they do while they're performing. Or the next level is in assessment, you actually have a personal conversation with them and figure it out. Lots of time-consuming things here in this end. But performance assessment and asking them what they think and how they think about and how they explain their results is one way to go about assessment.
That's a good answer. You know, I think you're right, though. This whole thing of performance assessment probably deserves a unique conversation by itself. So let's plan on that in the future. Let me, if I can, take us to a review of our objectives today, and let's see how we did. Today we wanted to develop a common understanding of blended learning terminology and technology. So we talked about that. We talked about what the basic principles were, and some of the technologies used from simulations to virtual labs and so on. And then we had several examples about how to develop blended approaches to instruction. We compared a conventional approach with a blended approach that was the titration, for example. And then Ava, in your section, we talked quite a bit about implementing blended learning using active learning, such as inquiry. And then we talked about those levels of inquiry. I learned quite a bit there about in my thinking about how to structure from one level to another. And then as we were wrapping up today, we talked about the instructional design principles for blended learning, how to organize your thinking and how to do that. So I think that was good. I want to invite participants to type in any final comments or questions into that chat window, which you'll see on the lower left of your screen. And Laura, will you give us our survey instructions while we do that?
Yes, sir. So before I have Ava and Mike answer any of the final questions, we have to do one more thing, and that is the survey. So I am about to display a quick survey on the screen, and I'll put a timer up for 90 seconds. It shouldn't take you more than a minute and a half to fill the survey out. And at the end of the 90 seconds, I'll take down the survey, and then we will go back to those final questions.
So please go ahead and click on your survey responses and then submit. I'll mention one thing while folks are completing the survey. That screen capture software I use, well, I didn't really know what I was doing, and so I did some Googling around and came up with the one called ScreenFlow. And I was able to use it in a demo mode, and I liked it enough. It cost $100, but there's a lot of capabilities there, and you can practice with it before you make a decision to buy. I'll say I don't own any stock in ScreenFlow. That's a joke, but anyhow, there's a lot of things out there, Snagit and other things. These things aren't hard to do. One of the questions was, how long did it take me to do that? Well, to be honest, I did 3 run-throughs to get it right, but I don't think I spent more than an hour on the entire thing, start to finish.
And Mike, I posted the link to ScreenFlow. I posted the link to ScreenFlow for the participants in the chat box if they'd like to check it out.
Okay.
And let me add here that I used Camtasia Studio, and there is a 30-day free trial period. There was a little bit of review I had to do, and it's a quite involved software tool, but it's possible to work with it.
Okay.
Perfect. So
your timer's almost done. I see it there. Yeah.
We have about 10 seconds left on the survey.
Thank you, folks, for doing the survey. It helps us pay the bills to the National Science Foundation, so to speak.
All right, so the survey has timed out, and again, thank you so much for doing that. Your feedback is invaluable to us. So let's go back and see if we have any final questions. I don't see any in the chat box. Mike, do you have any on your end from participants?
Yes, I do. Ava, you mentioned that, and I hope I don't ask this for you know, I don't mean for you to go on too long, but you mentioned during your presentation that you're interested in doing research in this area. When you do your research, what do you look at? Are there any of your research results that the audience might find particularly compelling in the context of today? I hope I'm not putting you on the spot, but I just thought you might have a little bit to tell us about what you actually do, what you research.
I always am happy to talk about my research, and I'm glad we had time for it. I did look into this a little bit, and I had a slide with references to my work there that we can, I'm sure, send to the participants as well. One of the things that I've done is compared what students learn with this virtual laboratory that was the second one that allowed the experimentation with the voltage and the concentration, and what do they learn with the hands-on environment, so that I could come up with this idea of how to combine the two. And so what I told you here came from that research study. One of the recent findings, and I've done this kind of studies with different students in different environments. Recently I did it with engineering students for a different study that I'm not talking about right now. But one of the things that I recently found was that not only do students actually learn content as well as design process with that particular software tool, but somehow their motivation or their active learning continues. And I can't point my finger on whether this motivation or whether this is, what is the process, what is the mechanism here. But that learning trust continues to the hands-on learning environment that they do after the virtual labs. So students who did the virtual lab before had significantly better learning than those who did the hands-on learning first and then went to just figure out what they actually did and what were the variables that they can look into after the virtual learning. So starting with the virtual lab in this environment works, and that's a really interesting finding.
Very good. Good. That's good. I mean, database decisions on these sort of things is very important. Now, I wanted to mention one other thing, Ava, and then we'll wrap up for today. If anyone would like a certificate of participation that showed that you were in this webinar today, and some people like that, you can email Shannon Payne, and you can see her address right there in the chat window. And Laura, why don't you go ahead and take us to the end?
Thank you very much. So this is Laura Sanchez again, and thank you all again for attending the Network's webinar, Blended and Flipped Learning Theory Overview. I received a couple questions from people asking how they can access the recording and the slides. You can access the recording, slides, and handout by going to the Maytech website, www.maytechnetworks.org. And the keyword search is Webinar Blended and Flipped Learning Theory Overview. And I'd like to just remind you that this is just part one of a two-part series on blended and flipped learning. We have the practical applications component next Friday, September 21st, same time. And you can register for that on our website, www.maytechnetworks.org. And you'll also see a list of the rest of the upcoming webinars for the new year. So again, thank you everyone. Thank you Mike and Ava, especially you both did a wonderful job and gave us some great information. And thank you for everyone who joined us. The webinar is now concluded. Thank you very much.
Thank you, Laura. Thank you again, Ava,